angular speed of the minute hand of a clock in degrees per second is A1, B 0.1, C 0.5, D 1.5. Over here we have to find the angular speed omega. The formula is given by 2 pi by t. Now this t varies for the seconds clock, minute clock and hours clock. Over here we have the minute clock. So therefore minute clock it will be 2 pi upon 60 into 60. If it is the seconds clock we will have only 60. Substituting the value of pi as 180, we have 2 into 180 upon 60 into 60. When you solve this, you get the answer as 0.1. Option B is the correct option. The angular speed of flying wheel rotating at 90 rpm is A pi radians per second, B 2 pi radians per second, C 4 pi radians per second, D 3 pi radians per second. Again we have to find angular speed, which is given by 2 pi n, but over here n is given as rpm. We have to find it out in rps, that is seconds. Therefore we will divide this by 60. So that is 2 pi 90, that is given to us, divided by 60. 90 by 60, that is 2 pi into 3 by 2. 90 by 60 is 3 by 2, 2 gets cancelled. We have 3 pi. Option D is the correct option. What is the angular acceleration of a particle in circular motion which slows down from 600 rpm to rest in 10 seconds? A minus 2 pi radians per second square, B minus pi radians per second square, C minus 3 pi radians per second square, D minus pi by 2 radians per second square. Where I have to find out acceleration. Acceleration is given by omega 2 minus omega 1 by t, but we know that omega is 2 pi n, therefore we will write 2 pi n2 minus n1 by t. Where n1 is given to us as 600 rpm, n1 is given to us as 600 rpm. m is in minutes, we have to convert it into seconds, therefore we will divide it by 60. 600 by 60 is 10 rps. This is our value, 10 rps. Now substituting the values, 2 pi 0 minus 10, 0 because n2 is 0 because it finally comes down to rest, minus 10, the 10 that we have found out, upon t, t is again 10 seconds, and when you solve this you will get minus 2 pi radian per second square. Option A is the correct option. Question 4. The length of the second hand of a watch is 1 centimeter. What is the velocity of the tip of the second hand in centimeter per second? A pi by 10 centimeter per second, B pi by 20 centimeter per second, C pi by 30 centimeter per second, D pi by 5 centimeter per second. So over here we know that V is equals to R omega. Substituting the value of omega as 2 pi n, but what is n? 1 by t, so this will be, V will be r2 pi by t. Now since it's a second hand, this will, now over here I have r, I have to first substitute the value of r is given to me as 1 centimeter, so this will be 1 into 2 pi, and since it's a second hand it will be 60. So that is 2 pi by 60. When you solve this, you get it as pi by 30. Option C is the correct option. The angular velocity of a geostationary satellite is A pi by 12 radian per minute, B pi by 360 radian per minute, C 17 by 720 radian, pi by 720 radian per minute, and D pi by 24 radian per minute. Over here, we have to find angular velocity omega, which is 2 pi by t. It's a geostationary satellite, so as our day moves, even it has 24 hours, so t will be 24. 2 pi by 24, but again it is written per hour because we have 24 hours. We have to convert these hours into minutes. Therefore, we have to multiply 24 by 60, that is dividing the overall equation by 60. When you solve this, you get it as pi by 720 radian per minute. Pi by 720 radian per minute. Option C is the correct option. A wheel rotates with a constant angular velocity of 600 rpm. What is the angle through which the wheel rotates in 1 second? A 5 pi radian, B 20 pi radian, C 15 pi radian, D 10 pi radian. Over here, here we have 600 rpm. We have to convert a minutes into seconds, so it will be 600 by 60. So this will be 10 rps. Now we have to find angle inscribed write in 1 second, that is 2 pi n, that is 2 pi, and this n we have just found out 10, so this is 20 pi. Option B is the correct option. Particle moves along circular path of radius r with uniform speed v. The angle described by the particle in 1 second is a r by b, b v by r, c v square by r, d v r square. So over here the angle described by a particle in 1 second will be given by omega. We know the formula of omega is equals to theta by t. Now here t is already given to us in the form of seconds as 1 second. So omega will be theta by 1. That is omega is equals to theta. Now theta in terms of v and r is v by r. So omega is v by r. Option B is the correct option. Question 8. A body is whirled in a horizontal circle of radius 20 cm. It has angular velocity of 10 radians per second. What is the linear velocity at any point on the circular path? A 10 meters per second, B 2 meters per second, C 20 meters per second, D root 2 meters per second. So over here we know that V is equals to R omega. R is given to us as 20 centimeters, but we do not have to write it in centimeters. We will convert it into meters. 20 centimeters is 0.2 meters into, we have already been given the angular velocity omega as 10 radians per second. 10 radians per second, so it's 0.2 into 10. That turns out to be 2 meters per second. Option B is the correct option. Question 9. A body moving in a circular path with a constant speed has a constant velocity, B constant momentum, C constant kinetic energy, D constant acceleration. Over here it will have constant kinetic energy because A, that is velocity, B momentum, and D acceleration, that all of these are vectors. So we have velocity, momentum, acceleration. All of these are vectors and they will change from time to time, or they will change from point to point. Therefore the only thing that will be constant is kinetic energy. Option C is the correct option. Question 10. A cyclist has to bend inwards while taking a turn, but a passenger sitting inside a car and taking the same turn is pushed outwards. This is because A, the car is heavier than the cycle, B, the car has 4 wheels and cycle has only 2 wheels, C, the cyclist to balance the centrifugal force, but the passenger cannot balance the centrifugal force, hence it's pushed outwards. The speed of the car is more than the speed of a cycle. So whenever there is a curved road and if a cycle is moving on the road, the cyclist has to balance out the force. Whereas if a car is moving on the same road, on the same curved road, the passenger or the driver will not have to balance. The car will balance itself automatically by its mechanisms. But in a cycle, the cyclist has to balance and move inwards so that the cycle does not fall. Thus, option C is the correct option. A turn on a slippery road at safe speed of 9.8 meters per second. If the coefficient of friction is 0.2, the minimum radius of arc in which the car will take turn is A 20 meter, B 49 meter, C 24.5 meter, D 80 meters. So over here we will use the formula mv squared by r is equals to mu r, but over here we know r is mg. Therefore mv square by r will be equal to mu mg. M and M will get cancelled, therefore v square by r is equals to mu mg. Now r will be equal to v square upon mu g. V is given to us as 9.8. It is v square, therefore 9.8 into 9.8 upon mu is given to us as 0.2 and g is also 9.8. So when you solve this, you get your answer as 49 meter. Option B is the correct option. Question 12. A train of mass 10 raised to 5 kg round curves of radius 100 meter at a speed of 20 meter per second. If the track is not banked, then the thrust on the outer rail of the track is A 2 into 10 raised to 5 Newton, B 3 into 10 raised to 5 Newton, C 4 into 10 raised to 5 Newton, D 5 into 10 raised to 5 Newton. So over here we have to find thrust The formula of thrust is given to us as mv square by r. We know this formula. M is 10 raised to 5. V is given to us as 20 meters per second, so it is V square, therefore 20 into 20. Upon R, that is the radius given to us as 100. So now when we solve this, we get 4 into 10 raised to 5 Newton. Option C is the correct option. Question 13. An automobile is turning around a circular road of radius r. The coefficients of friction between the tires and the road is mu. For the safety of the vehicle, its velocity should be more than A. root mu g, B. root mu g r, C. mu r g, D. mu g by r. We know that F is equals to mv square by r, and we know mv square by r is equals to mu mg. Over here m and m will get cancelled. We have to find velocity. Therefore v square will be mu, this r will go up, mu rg. Taking the square root on both the sides, we will get v is equals to root of mu rg. This can also be written as root of mu gr, which matches with our option B. Option B is the correct option. What would be the maximum speed of a car on road turn of radius 30 meter if the coefficient of friction between the tires and the road is 0.4? A 6 into 6.84 meter per second, B 8.84 meter per second, C 10.84 meter per second, D 4.84 meter per second. So over here we have to find out the maximum speed. The formula of maximum speed is root of mu rg, which is given to us, the mu is given to us as 0.4, r is given to us as 30. We do not have to change anything because it is already given into meters, and g is 9.8. So when you solve this, you will get your answer as 10.84 meter per second. Option C is the correct option.
The capacitance of a parallel plate capacitor can be increased by increasing the area of the plates, option B, decreasing the distance between the plates, option C, using a dielectric of higher permeability, option D, all of the above. Now to solve this question, we know that C, that is capacitance, is equal to epsilon A upon D. From this formula we can see that C, that is capacitance, directly proportional to the permeability. Now C is directly proportional to the area and C is inversely proportional to D. So all of these answers, the option D is the correct answer, that is all of them are correct.
16. A mass M is kept hanging by a rod of length L. What tangential velocity must be given to it so that it can just reach to the top of the vertical circle? A 5 root GL, B 4 root GL, C 3 root GL, D 2 root GL. So over here we know the tangential velocity half mv square is basically mgr, but over here r will be 2l because it has to reach the top of the vertical circle. So this is my vertical circle and this is length l. So it has to reach the top of the vertical circle. It will be l and l, that is 2l. Therefore half mv square will be mg 2l. M and n gets cancelled. Therefore I have v square is equal to this 2 goes over there, 4gl. Taking square roots on both the sides, I will have v is equals to 2 root gl. Option D is the correct option. Question 17. The body of mass 100 gram is tied to at the end of a string of length 1 meter. It is rotated in a vertical circle at a critical speed of 4 meter per second at highest point. The tension in the string at the highest point is, we have to take G as 10 meter per second square. A 0.3 Newton, B 0.6 Newton, B 0.9 Newton, D 1.2 Newton. We know that tension T is given by mv square by r minus mg. So mass is given to us as 100 grams. Speed is given to us as 4. It will be 4 into 4 because it is v square by r is 1 minus mg. Again over here mass we will take 100 grams and g we have to take as 10. So after we solve this, we get it as 600, that is 0.6, because this is gram, so we then later convert it into kilogram and then we get answer 0.6. Option B is the correct option. Question 18. To describe a vertical circle of radius 20 cm, the minimum speed of a particle at the lowest point of the circle is 10 meters per second. If the radius of the circle is reduced to 1/4 of its original value, then the corresponding minimum speed will be A 2.5 cm per second, B 5 cm per second, D 7.5 cm per second, D 10 cm per second. So over here we know that V min is equals to root 5 GR and V2 by V1 will be root of R2 by R1, because velocity is proportional to the root of radius. We know root of R2 by R1 will be 1/2, because we have been taken the root of 1/4. 1/4 has to be 1/2. Therefore V2 will be 1/2 into V1, that is 1/2 into 10, because V1 is given to us as 10. This is 5. The answer is 5. Option B, 5 cm per second is the correct option. Question 19. One end of a string of length 2 meter is tied to a body of mass 0.5 kg. The other end is tied to a small nail on the smooth vertical board. What minimum speed should be given to the body at its lowermost point so that the string does not become slack at any point in its motion along the vertical circular path? We have to take G as 10 meter per second square. Option A 6 meter per second, option B 10 meter per second, option C 8 meter per second, option D 12 meters per second. So over here we have to find the minimum speed. We know that minimum speed is equals to root of 5 GR. Over here we are supposed to take G as 10 centimeters, therefore this will be root of 5 into 10 into R. Over here R is given to us, smooth minimum speed at the lowest point. R is given to us, the length is given to us as 2 meters, so we will put 2 over here. So this will be root of 10 into 10, that is root of 100, that is 10 meters per second. Option B is the correct option. Question 20. A simple pendulum of effective length L is kept in equilibrium in vertical position. What horizontal velocity should be given to its bob so that it just completes a vertical circular motion? A root 5 GL, B root 3 GL, C root GL, D root 7 GL. We know that the minimum velocity is always root of 5 GR, where R is my radius of the circle. So over here if I have a bob of length, this is my bob of length L, which will move into circular motions. If this is going to move into circular motions, then this will be my radius. So instead of radius I will have the length L. So this will be root 5 GL. Option A is the correct option. Question 21. A bucket containing water is tied one end of rope of length 2.5 and rotated about the other end in a vertical circle. What should be the minimum velocity of the bucket at the highest point so that the water in the bucket does not spill? We will take G as 10 meters per second, A 2.5 meter per second, B 4 meter per second, C 5 meter per second, D 7 meter per second. So over here the velocity at the highest point is given by root of RG. R is given to us as 2.5 meters, therefore this will be root of 2.5, and G we are supposed to take 10. So this is root of 25, root of 25 is 5 meters per second. Option C is the correct option. Question 22. A motorcyclist loops a verticular loop of diameter 18 without dropping down even the highest point of the loop. Should be his minimum speed at the lowest point of the loop. A 10 meter per second, B 16 meter per second, C 21 meter per second, D 30 meter per second. We have to find the speed at which he is not dropping, so that will be minimum speed required, that is root of 5 GR. Over here we have not been given to take G as 10, therefore we will take the exact value of G without approximating it as 9.8. So this will be 5 into 9.8 into R. R is given to me as 9 because diameter is given to me as 18 meters. When diameter is 18 meters, the radius will be diameter by 2, which is 18 by 2, that is 9. So this 9 will come over here. So this is the root of 5 into 9.8 into 9. This comes out to be 21 meter per second. Option C is the correct option. Question 23. A body is allowed to slide down a frictionless incline under gravity from a height of 10 cm. The track ends in a circular loop of diameter d. The body is just able to complete the circular track. Then the diameter of the track will be A 4 cm, B 8 cm, D 6 cm, D 2 cm. So I have H is equals to 5R by 2. This is the formula. So from this we will get R is equals to 2H by 5. But over here we have the diameter D. Diameter is twice the radius. Therefore D will be twice this entire thing, that is 4H by 5. H is given to us as 10 centimeters, therefore this will be 4 into 10 by 5, which is 40 by 5, which is 8 centimeter. Option B is the correct option. Question 24. A body of mass m kg is kept at top of a smooth hemisphere of radius 5 meter. It is allowed to slide down the surface of the hemisphere. It leaves the hemisphere when its speed becomes 5 meter per second. What is the made by the radius with the vertical at the instant the body leaves the surface? We have to take G as 10 meter per second square, A 30 degree, B 60 degree, C 45 degree, D 20 degree. So here we know mg cos theta. We have to find out the angle made. So here we will write down the angle. The angle is missing in the question. Make a note of this. What is the angle made by the radius when the vertical radius? When the vertical instant of leaving the surface. So mg cos theta is equals to mv square by r. The m gets cancelled. So I know that cos theta is equals to v square by rg. Okay. So now cos theta will be v square. V is given to us as 5. So it will be 5 into 5. V is given to us as 5 upon r. R is also given to us as 5. And g we will take 10 because we have been told to take 10. So this will be 5 by 10, which is 1 by 2, which is 0.5. Okay, or we just keep it as 1 by 2. Cos theta is 1 by 2. So theta will be 60 degrees. So I have got the answer of theta as 60 degrees. Option B is the correct option. Question 25. The bob of a simple pendulum is suspended by a string of length 80 centimeter. What minimum horizontal velocity should put it to the bob so that it reaches the height of suspension point? So we want the minimum horizontal velocity that should be imparted to the bob so that it reaches the height of suspension point. We have to take G as 10 meters per second square, A 3 meters per second, B 4 meters per second, D 2 meters per second, D 5 meters per second. So we know minimum velocity half mv square is equals to mgr. M and M gets cancelled, and over here we have been given length of a bob. So instead of R we will write L. So this will be half V square is equals to GL. Therefore we will have V is equals to root of 2GL. This 2 will go there, which is equals to 2 into 10 because G we are supposed to take 10 into 0.8 because we have been given 80 but that is in centimeters, so we convert it into meters and write it as 0.8. So we have root of 2 into 10 into 0.8. When we solve this we get as 4 meters per second. Option B is the correct option.
The charge density of a charged conductor is option A coulomb per meter, option B coulomb per meter square, option C coulomb per meter cube, option D coulomb. Now to solve this question, as we know, charge density is nothing but charge upon area. Unit for charge is nothing but coulomb and area is meter square. So the correct answer is option B coulomb per meter square. The unit of electric flux is option A Weber, option B Newton per coulomb, option C volt into meter, option D joule per coulomb. Now to solve this question, we know that SI unit of electric flux is nothing but Newton into meter square upon coulomb, which is equal to joule into meter upon coulomb. which can be then written as volt into meter. So option C, volt into meter, is the correct answer. The energy density in the electric field created by a point charge decreases when the distance from the point charges. Now to solve this question, we know that energy density is directly proportional to E square, where E is equal to 1 upon 4 pi epsilon 0 Q upon R square. So we can say that energy density is directly proportional to E square is directly proportional to 1 upon R raised to 4. So now 1 upon R raised to 4 is the correct answer. So option D is the correct answer. The energy density in an electric field of intensity 200 volt per meter, if K is equal to 4 and epsilon 0 is equal to 8.85 into 10 raised to minus 12 coulomb square per Newton meter square is A. 8.85 into 10 raised to minus 9 joule per meter cube, 8.85 into 10 raised to minus 10 joule per meter cube, option C 17.70 into 10 raised to minus 10 joule per meter cube, and option D 7.08 into 10 raised to minus 7 joule per meter cube. Now to solve this question, we know that U is equal to half K epsilon 0 E square, which can be solved as half into 4 into 8.85 into 10 raised to minus 12 into 200 square, which on solving gives us 7.08 into 10 raised to minus 7 joule per meter cube. So option D is the correct answer.